Well, and wherever you are, as the has mentioned, we will dive into very innovative field in architecture, which digitalization and 3D scanning of spaces, objects, and whatever you can imagine. Really, this will be an overview of how the technology has changed in the last couple of years and what that means for everyone, not just architects and designers, but for every person related to the industry or even considering going into it. And yeah, what hardware and what software is. I'll give a few examples and then we'll um, let's say we'll do a conclusion and see where this could lead in the future, in the near future. Um, um, I'm not sure what your background is, so I'll start with this index where I will introduce the key concepts so you can be familiar with three key concepts about 3D scanning, how the technology works, and how everything comes together. Very briefly, I'm not going to dive too much into the technical side of things, but just enough so you understand how it works and what you need to make use of it. And then we'll reflect a bit on what that means for architecture and for everyone related to the industry. And then we'll dive into what hardware there is out there, what would I recommend, and I show you very friendly use one piece of software which is Canvas, how you can do these kind of things on your iPad if you have an iPad Pro, and then we'll dive into how IA is also changing this aspect, the whole 3D scanning, and then I'd like to make a point of how this could lead in the coming future. Um, Uh, um, well, for those who might have attended previous talks or not, we've been really interested in how we can make use of the latest technologies to 3D scan spaces and getting 3D model software or CAD software to produce documentation and for architecture or for engineering as such. We live in a very interesting moment where this technology is advancing really quickly. But basically, the main changes came from technology called LiDAR, and the recent additions to from artificial intelligence, uh, which I will show you in a minute. So, in a while since we have had in the construction industry or other engineering fields, laser technology to scan objects and spaces and things like that. But there used to be very it used to be more related to photogrammetry, which will take photos of the object, and then you will report back and create a grand database of that object. What LiDAR has changed is that this laser technology is used differently, and the laser basically sends an array against the object, billions and billions of them, and capture each and every point, position, location, color, and texture, and then that gives you this object that you see on the left. So this is a photo, and this is the object of what we call the point cloud. Those tiny objects that look like that is the reflection of those data points that have been projected in this case, on the Colosseum of Rome. And then with this cloud of points, we can work on today's software and produce actual architectural documentation. Um, um, Although this has been there for a while, I think most um, um, architectural professionals have lived or work with largely unfamiliar with this tool. Um, why is this suddenly important in architecture? What changes? Well, from my point of view, it changes how we work and how we design and how we edit the design that we considered before. It'll be a very manual work to survey a building and register all the small spaces, all the tiny small areas. And this will come with a lot of assumptions and interpretations from a technical mind that might not be so accurate. So it require a degree of interpretation of what was being seen. In this case, with this new technology, that kind of gets erased totally. So you could uh, scan a place, a single person could scan a place with a very small device these days, and and immediately, in a matter of hours or perhaps 24 hours, have a point cloud and an editable document that can be used for any engineering or architecture documentation purposes. This makes it A, faster, B, also quite efficient, and also the accuracy of that technology is 10 times full, which makes potential errors that we come across can be avoided early on by scanning the space. That will give us a design confidence of what we're looking at. How reliable are those plans or those documentations that we're producing? How much I think we can get closer and closer and closer to reality thanks to this new. But I think it will eventually change everything for on field. So basically, the process is relatively simple. For those who might have done surveys or familiar with engineering might have seen this before in the past, where you got a station and you position that station in different points, and you take dimensions in different locations, and you start building up a map of what's on the space or on the site. Uh, with this LiDAR technology I mentioned just before, which means light detection and ranging, is we are able to produce a much more reliable set of data. Before, we used to have what I mentioned before is the photogrammetry, which it would collect uh, a huge amount of photos, and from those photos, the software we were able to reproduce something close to reality. But it would used to look more like let's say if you're scanning this little barn, this agricultural barn, it would look more like you have dropped a blanket on top of that building. It doesn't really get very well to the eye, to the edges, to the corners. But with LiDAR, every tiny spot is not collected in geometry, but also in texture and color, which gives us this new uh, possibility to actually not just identify the geometry of that object, but also it gives us the extra layer of information that could be used for restoring building or for appreciating where the building has been damaged and where not. And this point cloud, it will give us geometry, color, and precision. And all of it will come with very basic tools, which I describe in a minute. The hardware has gone from the typical terrestrial tripod that you can carry on your pocket. Uh, um, uh, for those that might not be aware, these are the most used devices these days. There are two or three brands out there, but basically, this one that you see in the middle is Leica. That's the most common and most widely used 3D scan device when you are requiring a tremendous amount of detail and let's say the building is quite big and you need to use different stations. You probably are more inclined to use this kind of devices. For other this is the brand for those that are unfamiliar. And for those that might need to do a 3D scan of the actual outside, might be more welcome this DJI water-free adapter to your drone. But basically, imagine this large item in a tripod that you carry in different places to capture each and every room and each and every space as it is. That's what I've been going for a while. And so, in a matter of, let's say, hours, maybe half a day, you could scan a building easily with this Leica device, or even there are now some portable ones that you can just walk around, and it keeps on capturing information as you walk through, which makes it much more faster and accurate. This used to come with with certain level uh, uh, of training and preparation. Not anybody could just scan with these devices. You have to learn how the device works. You need to operate the device, and so you need to have some relation with the field of surveying or at least architecture to be able to use it. And this will lead you for a pre-training on BIM workflows or AutoCAD and other software alike. But we're in a stage that everything is changing, where this hardware is being replaced, and is thanks to these new cameras that are being installed on tablets and smartphones and other devices in the future. Any tablet user with a LiDAR camera can now today any um, space or or the entire building by themselves by just simply as taking a video of that space using certain applications. As you can see that this friendly user, which is I think the most widely used software in this occasion is Canvas on the iPad Pro. But I'm sure if you have other devices that have a LiDAR camera or a LiDAR sensor on your camera, probably any Pro version of Samsung or other devices will have the same. But any regular user with barely no training or knowledge can actually capture that space with simply taking a video with those applications, and that will be transferred into a software. As you can see, that is totally different to the technicality of carrying tripods, and this has happened within a space of 5 years, even less probably. And I think we haven't finished seeing these changes. There are other softwares out there, not just Canvas. Canvas is probably the most affordable at the moment, the most cost-effective one. But there is also Matterport, which is very famous for those who want to add an extra layer of information. But we found the work we do is that Canvas is very user-friendly, and any of your potential clients or collaborators can use it with almost no training, as I said. Um, So you imagine you a new project or a new space that you want to change, or you just want to capture it and see what you're going to do with it. You can simply put this up on your tablet, make a video of the space, and this will be transferred directly. And the output of that video uh, is not automatic. You will capture that scan, and that will be processed on the app. It will take a bit of time, and then you will get an outcome on three different fields. Basically, you have existing floor plans. You have the version of a photographic tour of that 3D scan, which you can see might be you can see it's a bit patchy. It has pieces that are not entirely together, but you to understand this output is what we saw before as point cloud, but made into a more clear image that you can recognize. I'll try to launch one so you can see. So basically, 20 minutes walking around with your iPad, you wait for a few hours and you have automatized floor plans and 3D of this space. And you can ask that on any software that you might be using, from SketchUp to AutoCAD to Vectorworks, Rhino Zeros, anything that you're using, Revit, and to use it as a real document I'm working on. Up to there is fantastic, but I must say there is a caveat here that that model that comes out still needs a bit of interpretation, and so you might have to clarify a few things that the server might have not understood very well. Minor things. It's not, it's not like you're just gonna miss a room or it's gonna miss a door, but you will have to do a first pass of interpretation of what you're seeing, because maybe there's some objects that has not been able to interpret it correctly. Let me show you one of these scans. Hold on a second. Let me see if I can share with you one of these scans. It's gonna stop saying 1 second, and I'm gonna launch it in another window, so you can see how it's easy, how friendly and easy it is to use uh, for those who want to venture into the. Hold on a second. Oh, it's not working. Um,
I'm reminding you, brothers and sisters, you are with Atlantic International University, and today our Antonio Berrio is making a presentation in the arena of architectural design. So be patient, please, as we are
Sorry.
resuming the presentation. There it is.
This will be the outcome of that 3D scan.
Okay.
As you can see, this is on the web, as you can see my screen. So it's, almost any equipment, any laptop, any user can access it. And as you zoom in, it's not just a photo. It's those little millions of dots have been collected and put together into an actual 3D, let's say, surfaces where you can see most of it. As you can see, it's very patchy. It's not perfect, but this is quite interesting because now you can see the space without having physically to be there. So let's say you're working in New York and you have a project in Australia, and for whatever reason you can't make it there. You can, your client can, before you actually can travel there, you can actually ask your client to scan that with their phone, and you will have this on your um, at your disposal in less than 24 hours. And not just this, you will have perfectly fine floor plans, which I'm trying to learn now, ready for you to start working. Uh, start working on. As you can see, these are very basic, but you got what matters the most to you. You got the dimensions, you got the position of window, door, and even any object you might come across with fixtures, toilets, and that kind of stuff. Uh, um, what it makes it very interesting is that you can work remotely using this software, and even if hold on a second. Um, And even if it's something you can't understand from the floor plans, you can come back to this 3D and literally just tour the house or the space. Let me show you another one. Just one second. I just have another example to share with you. It's just a little slow because obviously I'm on the Zoom call, so it just takes a minute to launch. Uh, there you go.
Just be patient. There it is coming up.
There it is. I
Yes.
hope you can see it now. Yeah, so this is a different project. The other one was first floor of a residential building. This is the basement, and as you can see, it's pretty close. High register, all the pipework, all the structure. Let's you see have capture where all the cabling, wiring, everything is, which is it's pretty decent if you ask me, it will take you quite a bit of time to actually capture all of them manually. And with these tools, in a matter of hours, you can have a pretty good understanding of the space, all the MEP and potentially structural elements. This, what you see, is not the full scan. We found out that you can produce a full scan and receive entire 3D, but sometimes it's not necessary if the space is there, like this one. But you could request to have a 3D model of the space of the entire building in Revit or in SketchUp, for example, and you could have a complete view of this scan as well. Um, like I said, you're looking at a work document that it was done with the sole purpose of reproducing the floor plans, the existing floor plans, and take an understanding of how the space looks like in real life. Um, um, and that's the floor plan again. So you can get a pretty good idea of how Canvas works. Like I said, you can open this on a browser, you can open this on an iPad or on your phone. So it's a complete radical change because you don't need um, you don't and equipment uh, power either uh, to the presentation. Where do you go?
Remember, ladies and gentlemen, you may write down your notes and get ready to ask questions as we're gonna dedicate the last 10 minutes or so for your questions, aspects of the presentation about which you might need some clarifications. So take notes, keep
Thank you.
listening, being patient, and get ready to ask questions.
Thank you. Thank you, sir. So yeah, this is we're back to the presentation. So you can at the end of each slide, I have left a link. So everyone, once you get this in PDF or like we always do, you will be able to navigate these models as well if you like. So you can test it out. This canvas is not free. You could access that link for free, but if you want to use it, there's no free trial or anything like that. But I must say that you could you could give it a go because the cost is minimal and it doesn't cost per item, it costs per square meter, so it's quite reasonable for those who want to try it out. Um, and then the next step in the evolution. So let's go back just for 1 minute. These tripods, that was the traditional surveying, engineering, and architecture theories. But there is this new low cost that you can do on your iPad, on your phone. But basically, probably a few months old, artificial intelligence has come and disrupted this as well. And it's something that I want to bring together for you to fully understand reality scan or reality capture, where you can actually find artificial intelligence applications now that you can just provide them with a photo of the object or the area, and it can reproduce the object in 3D. The most famous or used one, at least for us, is 3DA Studio. It's very friendly as well. It's web-based as well. But if you can consider that, for example, I took this photo of a chair and I just uploaded that photo, and I will give me a 3D model, editable 3D model for Revit or SketchUp. Let's say you are an interior designer, for example, or an architect, and you want to really give that real feel of what you're gonna put on the space. That share that will make the difference to the look and feel of your project. But you don't have the time to sit there and model to perfection that item to a level that it will just look right in a marketing 3D rendering. You can use this reality capture application, uh, which is online, is inexpensive, and capture those items that are difficult to model or difficult to produce. Within minutes, you will have an editable 3D model to put in your project. You can see some of the items that we have tried out. You have tried out sculptures, pieces of furniture, even flowers, anything is scanned now, or at least so we can almost bring spaces, objects, almost anything you can think of into the 3D, into this 3D reality or digital reality, where we can play with it, edit it, and change it. In this application, also, you can actually do much more than this, but you could decide to produce textures and capture textures and other items. So it's much more complex than just that. But for you, if today you're taking something with you, is that there is an application on the web that you can actually transform regular photos into 3D models that you can bring into your project easily at a very low cost and with extreme high definition. Um, uh, this demonstrates how these objects, everyday objects that used to be accessible through 3D libraries, perhaps very expensive to use, have become much more accessible, much more democratized for smaller companies or smaller architecture practices in almost no time. So this, as you can see, this is changing how we operate and how we produce and edit documents in 3D. I have, like I said before, I have left a link down there for those who want to give it a go after. And then, if you allow me, in the presentation, I'll go back. We've gone through this very complex photogrammetry quality capture, which involved tremendous amount of energy and hardware and technicalities, let's say, to much more sophisticated LiDAR scans that allows you with a bit of knowledge, scan a space, and use it for your work or your design. To even further than that, where we capture spaces, objects in 3D with our cameras or tablets or phones. Where that would go from here, what that means for us in the coming years. Well, allow me to invite you to information what will happen with the reality scanning in the coming months. But there is some suggestions that the smart glass is, as we speak, could become this new object that will actually capture reality to a different level. Right now, these smart glasses from Meta and other VR are starting to get pretty sophisticated and pretty small, where you can actually just project stuff on the glasses, but they can actually sense space using LiDAR technology again to identify objects in nearby or spaces, or simply mapping the area around you to give you more information. This this is, companies are using it right now to produce what we call enhanced reality, where you have all sort of information being projected on your glasses. But what if this the same technology, which is already there, could be used to scan or map your experiences, but not just by taking a photo like we do now, but we could quite easily capture and collect experiences of spaces to objects to the noise, using these devices, collecting it into a digital world, um, and that would allow us to revisit them one day if we need to, let's say we go back to that hotel once, because we think it's going to be very interesting to revisit that experience. With this technology, you could potentially store a huge amount of information and data of things that interest you, and be some sort of collector of information that is widely available in reality. And you can use it to design your projects, or simply to enrich your knowledge of the world, or you simply revisit what you designed in the past with new eyes. What if you, as you can see, not just you got all the information on the weather and the time, but what if you could, at any given time, record what you live in, uh, uh, um, and not just a video, but the space to offer you a possibility to go back to that scene, uh, uh, I visit the project in Asia, and you don't really have the means to keep going there every other week. You could simply capture that space and see, keep on revisiting it while you're doing your work. It gives you the possibility of experiencing that space and edit the space by effortlessly walking through with your smart glasses. Let me show you what this might. Hold on a second. I need to stop sharing. I need to open another of those links. Let me show you what this could, how people is envisioning this. Hold on a second. It's a bit slow. Mm, Sorry, it's getting stuck. 1 minute. This is a simulation where you could capture, your experience working on the field with your VR glasses or smart glasses. Um, this sort of enhanced reality where you could, you know, uh, play your software and all that. This is where things fit into you. You have a memorable experience of the day, and you capture it to, projects or to uh, to redesign a space later on when you come back to it. Be quite interesting change because you're not just capturing photos or objects or 3Ds, you are collecting experience in all their dimensions from from the geometry um, to the light to the textures. It could be quite enriching from a professional point of view, but also from a personal point of view. And let me go back to the presentation now. Oh, sorry. There you go. Um, yeah, so we started the presentation talking about capture reality. Uh, uh, but as you can see, technology has evolved towards capturing almost anything that you experience to a level that it will give you access to a tremendous amount of data that could be at your disposal to make your projects better or more interesting. So you could potentially, um, uh, let's say, go back in time on your days and collect, hour that you used in your design chair that you remember seeing in an exhibition in the Netherlands, and just reproduce it and begin in the space, see how everything works out. Um, the the level of versatility that this could give us as designers and or architects, it could change. Um, it, because as you can see, everything is becoming quite easy to do with just walking by with a small device, which means the cost will drop. Uh, um, the training is almost none, and then the speed has multiplied, like I said earlier, 10 times, which it will be a window to the future where you could uh, see many more alternative designers playing with resources that nowadays are not easily accessible because of cost. Only big companies can do. So this is kind of uh, offering you the opportunity as an architect or designer to design anywhere in the world, capture reality anywhere in the world, wherever you are, any object, and bring those into your projects almost at a very low cost, almost free, let's say, which it will or is already revolutionizing how the industry works. And just finish. I'd like to thank you all for listening to this, and also I would like to leave you with a very famous quote: "The most profound technologies are those that disappear. They weave themselves into fabric of every design until they are indistinguishable from it." So if we see this technology of scanning 3D almost disappearing into our wearables, which already is happening, because your phone you put in your pocket, what would you do with it? That's the question I would like to leave you with. How can you make use of that? I can think of a million things that it will benefit in my projects. But I like to throw that question out to you, and if you want to try those apps and um, those websites, they will be for those. I can see somebody has raised their hand.
Before we go to the questions, I want to thank you very much, Antonio Berrio, for your really high-class presentation. You have explained to us how modern technology can be used in the arena of architectural design to make the field kind of better to whatever extent. Ladies and gentlemen, we have enjoyed a class about how reality can be captured with unprecedented speed and accuracy, enabling architects to design with a high level of confidence, saving time, reducing risk, and making outcomes gradually better every day. I presentation that makes Atlantic International University what we are, like we've been for the last 27 years or so. We are a pioneer in the field of distance education, and definitely Antonio Berrio has significantly contributed to this standing. Thank you very much, Prof. The question you apparently are ready to answer, beginning with Ismail Adebola. We are all ears, brother.
Thank you, sir. Good morning, sir.
Hi.
Hi, sir. Good morning, the presenter. Good morning, everyone.
Good morning,
yeah, my question is tending to hardware and software. Yeah, let me ask the question quickly. Yeah. By discussing the interplay between hardware advancements and software capabilities in the realm of architectural design, how might future development in these areas drive innovation in the industry?
Well, you could say 95%. Without the hardware will be nothing.
Yes.
That small change of putting the LiDAR sensor on the smartphones has catapulted all these new startups, which they were non-existent a year ago, or less than a year ago. So yeah, they are fundamental. Hardware is key player in all of this. I don't know if that's answering your question or you have any further comments on that.
I believe you are right on target. Thank you very much. Ladies and gentlemen, reminding you that this is now your time. We have a full 15-minute period for you to jot down your questions and voice them, or if you prefer, you may as well go to the chat block, the chat area questions, and I will find pleasure in reading them for our SME. The second question now is with Santam Duganda. If you are ready, so are we, Santam.
Yeah, good afternoon, Miso. Good afternoon for everyone. My question is this. I would like to know the importance of the hardware software ecosystem in that of the healthcare. It is as important in that of the healthcare.
Sorry, can you repeat it? I can't hear you very well. Sorry.
The importance of the
just try to go a little slower.
The importance of the hardware software ecosystem in that of the health.
importance of the hardware and the software. That's what you are asking, right, Santam?
Yeah, I think it's more software. I think he said. I think right now everything is still all this new software still relates to AutoCAD and Revit. Any capture that we have seen today always goes back to the famous AutoCAD or Revit or BIM models. There are other formats out there, but right now that's the industry standard. So however new this software is, they always go back to the original and most widely used AutoCAD formats and Revit formats. And that obviously is not just the only option, but whatever software development happens in the field, end up going back to the mother source, let's say, which was the traditional architecture software, AutoCAD or Revit.
All right, thank you very much, Professor Berrio. Santam Duganda, whom we couldn't hear very well, has also input some type of addendum in the chat box. I'm trying to understand the relationship between architectural design and healthcare, but of his question, which he wrote as follows: the application of the hardware and the software ecosystem in areas of healthcare. If that
Okay.
rings a bell for you.
Well, thanks to bringing that up because we've been focusing mostly in design and architecture in general, but there is an extra layer of information where you could capture or you could scan information from a healthcare building and add an extra layer of information in it, which I'm not sure if any of you have heard of it, but you could create a digital twin, which is what most maintenance companies of healthcare facilities are doing to monitor the health of the building and the state of the building in real time. Basically, they digitalize the building 3D, but not just the 3D, but all the parameters associated with the building, airflow, electricity, energy consumption, and it's attached to that 3D scan that we just saw before, and that will allow them to much better administrate and save energy and maintain the quality of the air available. So, for those who are interested in architecture in healthcare, these technologies have had a tremendous impact because now facilities all over the world can monitor buildings in real time, and any of the professionals can access the building and understand why this has a worse air quality and this area has a better air quality, how that affects the people. But the source of this complex, much more complex than this 3D model, is the same LiDAR 3D scan of the existing structure.
All right. Thank you very much for your addition, Antonio Berrio. Moving on with questions, Annelisa Wassel-Dean wants to voice a new question. And I just turned your microphone on, Annelisa.
Yes, good morning. Thank you, presenter.
Morning.
I just want to know what percentage of AI does this technology use, and is it possible for AI to take over architecture?
Okay, I love that question.
That's a very tricky question. Right now, the LiDAR technology doesn't require artificial intelligence, so you will be able to work without it. However, as you have seen in one applications, uh, um, it is taking over at least partial parts of it, which with the potential of taking over all the 3D scan capabilities, because now LiDAR is also including artificial intelligence into it, which is, again, is not absolutely necessary, but it's facilitated things. Where that is going to take over, well, if artificial intelligence is going to take over our jobs, our professions, that's a much bigger question, and it's very difficult to answer. I think if it's not done correctly, it will. But I want to believe that it will be done in such a way that it will empower us and not just declare us redundant, basically.
I agree with you fully. Ladies and gentlemen, just take full advantage of artificial intelligence, but don't let it take your spot in the world of business, including in architectural design. Ismail Adebola, I know you are very eager to get deep into this field, so we are granting you another opportunity to ask another question. Go ahead.
Thank you, sir. Yeah, my second question is similar to the uh, the student that just asked the question. Well, let me put it this way. It's still on artificial intelligence, but there's a question. By considering the ethical implications of using artificial intelligence to convert images into 3D representations, how can architects ensure that such tools do not compromise their creative vision or authenticity? Right.
Yeah, that's a very tricky question, because something must be done. I think is a very good question because something must be done in terms of copyrights and things like that. So you should be able to scan it, but you should also be able to pay tribute to those who originally designed it or produced that item. At the moment, there's nothing, absolutely nothing. I know there are ongoing discussions on the field on what it should be protected and what should be allowed. Should be allowed. From my point of view, this has happened in the past. Many architecture students have gone in trips to Greece, to Rome, to visit the lost temples in Cambodia, and nobody was charging them for for visiting the space, right?
Right.
So they, to a certain degree, I think scanning the spaces in heritage buildings probably should be protected. However, scanning certain items that you come across or you have purchased, or it should be something to make proud the original designer, but it shouldn't be so compromised because then you will kill the industry altogether. I think if you allow, if we were allowed to visit those spaces and enrich ourselves as professionals just in visit, the fact that you will be able to scan that space and revisit it, perhaps even children in the schools could revisit those spaces. It wouldn't reach all of us. I think it will give more. We will gain more than they will lose from have a replica in 3D of those spaces.
Thank you very much. There are no other students or participants raising hand for questions at this time, but let me voice one of my own. This is not a field of great interest for me, architectural design, but I want to learn as much as possible. And there is one very specific dimension that's kind of far away from what we have talked about today. The emphasis was on the advent of technology and all the implications of that. But when it comes to technology in general, one key factor is the availability of money. We must have money to use technology at the maximum, so to speak. My question then has to do with what is possible, what can be done for people who are architects but live in an environment that is deprived of financial possibilities. What is their hope? What are the possibilities or options for these people who don't have money, but they still want to take full advantage of modern technology in architecture, Antonio?
Well, that's a very good question. Thanks for bringing that up. But I think I mentioned at some point on the presentation that this, the fact that the technology is getting smaller and more affordable is democratizing the field a little bit. There will always be some cost associated with it, but the cost has dropped dramatically. So you can think about it like, when the mobile phones arrived to developing countries and everything started to change very quickly because it was almost it was tremendously inexpensive to purchase an old mobile phone, but that changed their life. I think something like that could happen with the introduction of artificial intelligence. Like the cost will drop dramatically to the point that people with very little resources will be able to access it. How little, that's to be seen, obviously. But I can tell you from experience that if a small studio of, let's say, two or three young architects uh,
Pull together.
nowadays to scan a property in the Caribbean where they cannot afford to bring an entire team to do a survey of the house, but now thanks to these technologies, you can. That just by itself immediately it makes the group of three much more uh, um, um, you know uh, it gives them access
Affordable.
to the market, right? That before they wouldn't have, because they would not be able to travel all the way to start designing a house in the Caribbean, right? And this is happening today. So in a way, where is the limit of that? I'm not sure, but consider that this was not possible 5 years ago, and small studios of architecture were limited to local projects. The same happening with IA and with artificial intelligence. If the fact that very little resources are required to, to convert a photo into a 3D model, that immediately means that you need less computer power to produce a 3D model. You need, at least locally, you need less computer power. You need less, you need a cheaper machine. You need so everything becomes much, much more accessible to everybody. But there is a dark side of all of this, is because that is happening. There might be a tremendous increase in competition, right?
Yes.
Many more alternative designers, many more architecture minds out there, which will make it harder for people to stand out. But you can't have one without the other, I think.
All right. Thank you very, very much for shedding some very bright light onto my question. And I hope every participant has taken advantage of your clarification, Antonio Berrio. Ladies and gentlemen, we have come down to the end of this presentation, which to me was one of the best, despite the fact that too many questions, but I'm certain that you have thoroughly enjoyed this presentation by Antonio Berrio. And we cannot wait for an opportunity to have you again, Antonio, as I'm turning back to you at this time for your concluding remark, if you will, please.
Well, thank you very much for your kind words, and thank you everyone for your questions. That made the class much more interesting. if you have to take something from today's class, is that there is technology out there that could allow you to empower you architecture design, and it's quite affordable. And thank you again for your attention today.
Thank you once again, and thank you to each and every one of you, our very beloved participants. And again, as I said yesterday, we will be doing that at every opportunity, wishing you a quite happy holiday season.